vagus nerve function can be affected by many, many different factors. So we're talking things like dysfunctional breathing, definitely unresolved emotional toxicity, which basically equals chronic stress. The weaker the vagus nerve is, the poorer our ability to handle stress, of course, as well. So that's a very important factor. Then we've got things like dysfunctional digestion, like eating too fast or eating too stressed, poor liver function, poor pancreatic function, chronic inflammation. All of those things affected. Dysfunctional sleep, another one. Vagus nerve can get toxic as well, because obviously our nervous system is predominantly fat tissue, and that's got high affinity for toxins. So all of those factors affected, but one of those things that can affect vagus nerve function is infections. And there's this interesting hypothesis, because it's not conclusively proven as yet, but the guy's working on it, as you said, Michael van Elzacker. And so the hypothesis really says that an infection of the vagus nerve can cause an exaggerated chronic sickness response, like fatigue, brain fog, pain, those sort of flu-like symptoms, really. And this was the focus of his original paper from 2013. We just remember the title, Chronic Fatigue Syndrome from Vagus Nerve Infection, a Psychoneuroimmunological Perspective or Hypothesis, something like that. And so basically the idea here is, or what he proposes is that when molecules are released by different type of innate immune cells, so white blood cells, glial cells, mast cells, those glial cells, by the way, play a big role apparently, they release pro-inflammatory cytokines, and those are molecules that then call other immune cells to the site of the infection and the area where the injury or infection occurred, to then cause more activation of the immune function to fix the problem. And so particularly glial cells actually pick up quite a lot in presence of viruses, and they can release all sorts of cytokines, those pro-inflammatory cytokines, but also other neuroexcitatory compounds, things like interleukin 1b, interleukin 6, TNF alpha, glutamate, prostaglandins, free radicals. There's all sorts of things going on. But what then happens is the behavior changes. So you basically feel more tired, unrested, you may feel sore, you may feel like you don't want to do any thinking, that kind of brain fog type of thing. And so what he proposes is that it's the receptors of the vagus nerve that almost like, he calls the vagus nerve, what did he say? It's detector of the infection. And so those pathogens that we're talking about, obviously he's talking about primarily viruses, but not all, also there are other things like Lyme disease, like Borrelia bacteria and stuff like that. But we're talking about different types of herpes virus, Epstein-Barr, cytomegalovirus. So interestingly, all of those pathogens have actually been connected to the chronic fatigue syndrome. And so he says it's almost like this explains why people have chronic fatigue syndrome with those different, essentially those different causes, if you like, different pathogens causing it. And there was this study at the University of Colorado where they injected rats with E. coli bacteria, and the rat would get sick. And of course, when the rat got sick, it didn't want to run, it didn't want to eat, it didn't want to socialize, so it displayed that sickness behavior. But when they cut the vagus nerve, they actually found that the rat behaved normally. So it's almost like the rat didn't know that it was sick and infected with this bacteria, which was really interesting. So that kind of prompted him to form this hypothesis that, what if it actually is the infection of the vagus nerve itself that signals the brain, and hey, we are sick, and causes this exaggerated behavior symptoms. But the interesting thing is that he suggests that it's not so much the severity of the infection, it's not so much which pathogen it is exactly, but it's more to do with the fact that the infection is localized and it is in or within the vagus nerve. That's the crux here. So in other words, you could have latent infections because, you know, things like Epstein-Barr, some of those herpes infections that people have, they're not necessarily full-blown infections, right? These are kind of low-level, latent. Sometimes those lyses can be latent, and sometimes they're very low-level infections. But it's because of the location and the vagus nerve being the nerve that signals this to the brain and says, hey, we are sick now, produce the sickness behavior, that behavior can be quite exaggerated, and you can have this extreme fatigue and extreme brain fog and anxiety type symptoms. So it's not necessarily the severity, but the location. So that's the interesting thing about it. So really, we're talking about, we're basically ridden with pathogens, right? We all are. And when the immune function is strong, those are kept under control, they're kept in check, and essentially it's not something that is symptomatic. But then when we have, for example, a stressor of, well, let's say a trauma, let's say there is actually a period of stress, we know that this is why he's talking about psychoneuroimmunological perspective as well, because we've got this intimate connection between our nervous system, our endocrine system, and our immune system. And so we know that chronic stress, for example, will lower immune activity. And let's say that's the situation. We can, and people will relate to that, because I'm sure, say herpes, for example, herpes virus, you know, you get, your immunity gets a little bit compromised, and suddenly you come out with cold sores and things like that. So that's what we mean. They're sort of there, but they're not really causing us a problem as such. But if the immune system is a little bit off, let's say, that can come to the forefront and it becomes symptomatic. So that's what we mean by that.
You mentioned the glial cells. So it's causing a reaction in the glial cells, which are in the brain. That's why it's the vagus nerve communicating with the brain and telling it, okay, I'm sick, there's something going on here.
Yes, so the glial cells are neuroprotective cells. So the immune cells that are neuroprotective cells. And so they protect the vagus nerve as much as they protect the other neurons as well. But obviously the key here is that they are known to regulate this nervous system signaling. And this is why they can be so highly reactive if there is an infection in the vagus nerve. And it's been suggested that when it comes to treatment of those chronic fatigue syndrome and related conditions, that actually stopping that glial activation may be easier and more effective than just going after the virus alone, right? So there are various glial cell inhibitors type supplements, for example, things like curcumin, resveratrol, cinnamon, CBD. Some of those things have been shown to stop that exaggerated glial cell activity. And then if we put antiviral treatment maybe on top, maybe we go for some herbals and stuff like that, we can actually have a better effect in terms of addressing that problem. Can I just add actually that when it comes to vagus nerve infection, I think personally it's also important. So the glial activity, addressing that, addressing the virus itself, but actually encouraging the vagus nerve to work properly, make it come online with some of the strategies that we're going to share later. I think it needs to be part of the strategy, because that's when you really get more of an impact really than if you were going after those things separately.